Hi, in this video we're going to continue talking about the distribution patterns from MultiCloner, and in particular we're going to talk about the level of detail distribution. In this scene I just have a plane and a null, which is going to be the center of the level of detail, and I have three cubes, each colored with a different color: green, red, and blue. I'll create a MultiCloner object and parent the cubes to the MultiCloner, and I'm gonna set the plane as my distribution geometry. So right away we get points, and we see that these points are actually colored differently, and this has to do with how many children we have. So if I set my distribution to a linear distribution and I increase the count, I would start to see the significance of the point color. So if I make this slightly darker, I see that I clearly have a light green, green, and then darker green, depending on how many children I have. So if I had more than one children, let's say I make a copy of these and update the distribution, then I'm going to have a gradient of 6 colors that I have. Of course, increasing the clone count will show you this gradient in more detail. So the colors have to do with the distribution of the points. Alright, and whenever you turbulence the distribution, then you see the actual pattern displayed very clearly. So according to what you see in the viewport, you're gonna get the render give you the same thing, except for here the cubes are too large, so I would just need to reduce the clone size to get the same pattern that I have in my viewport. Okay, so now we know the significance of the color, but in this video I want to talk about the level of detail center, which is over here, which has to do with the level of detail distribution pattern. Okay, so if I choose the level of detail distribution pattern, first I'm gonna set my clone count back to 1000, and I'm gonna just have 3 children, so I'll delete the other 3, and here I'm gonna take my null and set it as the level of detail. So the color changes, and let's set the display as actual geometry to see what we have. So I'm gonna reset the turbulization of the distribution to the defaults, and now if I grab the center and move it, and here I'm gonna lower it down, I see that the distribution happens according to that center. So why is this useful? First of all, I can separate the distribution according to a custom position that I want. That's the first advantage. And the second advantage is that I can use clones of different resolutions. For example, if I was creating a forest and the null was the camera, and I want the trees that are closer to the camera to have high resolution, the red ones I want them to have medium resolution, and the green ones low resolution, I can do that, and whenever the camera moves, that resolution change is gonna follow. So that way I can control the resolution and therefore the rendering, because when you reduce the resolution, you'd also be reducing the amount of leaves and so forth, and these outer trees, in case there were trees, would render at a faster speed. Alright, so having done this, you can play with the minimum distance, so reduce the minimum distance, which is the distance of the first clone, and then play with the outer distance to control the radii of distribution. Also, you can turbulence this distribution, and to see this clearer, I'm gonna set the clone amount to 10,000. So here I did increase the turbulization. It doesn't look very nice though. In case that was the result that I'm going for, then fine. Otherwise, I would increase the turbulence scale, and I would get this. Remember that I'm seeing the 10,000 clones here in the viewport. It would be better to show them as points and keep the points visible. Yeah, so now that's more manageable and it displays in real time. And of course I can play with the fine distribution to have more detail, more blending between the different clone types. So this is a very nice way to actually control where the actual center of the turbulence is happening. So that's the LOD, or level of detail, type of distribution that we have over here. Now this object, the level of detail object, or the level of detail center, is also useful later for the filtering. We have something called the filter by center, and we're gonna see this later, but it does require a level of detail center for this filtering type to be effective.